Okay, welcome back. This is Mr. Hassan's Maths channel, and I am now going to proceed to answer question number 3 from the October 2024 Pure Mathematics P4 paper. This is from the Edexcel International A-Level exam. And here we have a question about parametric equations. Here we're told that figure 1 shows a sketch of the curve C with parametric equations x equals sine cubed theta and y equals 1 plus cosine 2 theta. And theta is between minus pi over 2 and pi over 2. So first we've got to show that dy dx equals k times cosecant theta, where theta cannot be 0 and where k is a constant to be found. So we've got to find dy dx given x equals 3 sine cubed theta and y equals 1 plus cosine 2 theta. Okay, so now dy dx in a parametric equation is generally found by using the chain rule. Okay, it is possible, okay, to find dy dx by making a Cartesian equation, but then we won't have it in terms of theta, it will be in terms of x. So if we make the Cartesian equation and then find dy dx, we won't get something in this form. So when they ask us to give this in this form, like a lot of students say, why can't I just find the Cartesian equation and then find dy dx? Well, you won't get something in terms of theta then. And also that's a lot more hassle. Although in this question part C, they ask us to find the Cartesian form of the equation, it's a lot more hassle than what I'm going to show you now. So we've got to find dy dx, and we're going to do that using what's called the chain rule. Okay, this is something to do with, you can relate it to the related rates of change that we study also. But basically, we want to find dy dx. Okay, but we don't have y in terms of x. But we have y in terms of theta and x in terms of theta. So if we find dy d theta and multiply it by the reciprocal of d theta x, which is d dx d theta, which is d theta dx. So the reciprocal of dx d theta is d theta x. You can see that that's going to give you dy dx in the end, because the d thetas will cancel out. So we have y equals 1 plus cosine of 2 theta. And we have x equals 3 times sine cubed theta. Now I'm going to write this as sine of theta cubed. That'll make it easier for us to understand what's going to happen next. All right? Now for y, we find dy d theta. 1 becomes 0. The cosine of something becomes the minus sine of the same thing. Then we multiply by the differential of what's inside the function. So we multiply by the 2. So we multiply by 2. So you end up with minus 2 sine of 2 theta. That's using the chain rule. And here, again, we have to use the chain rule. Dx d theta is going to be, so the main function here is something cubed. Here, the main function was cosine of something. So you differentiate cosine of something becomes minus sine of the same thing. And then you multiply by the differential of what's inside the function. Here, the main function is something raised to the power of 3. Very important for us to be able to recognize what is the main function and what's the function inside the function. Okay, all chain rules are going to be f of g of x, basically. All right, so the function inside the function, we have to recognize what it is. When you differentiate it, you differentiate the whole function as it is, and then you multiply by the differential of the function inside. So we have to recognize what is the main function. In this case, it was cosine of whatever, and that whatever is 2 theta inside it. So you do differentiate cosine of something becomes minus sine of the same thing, then multiply by the differential of what's inside it. So you end up with minus 2 sine 2 theta. Here the main function is something raised to the power of 3, and inside it is sine of theta. So how do you differentiate something which is raised to the power of, it's like a polynomial type of function, raised to the power of 3. You multiply by the power, so 3 times 3 gives you 9. And then you differentiate, well, you leave this as it is, because it's like the main function. You multiply by the power and you take 1 from the power, and then you multiply by the differential of what's inside the function. Now, if you differentiate sine theta, you get cosine theta. So we're left with, in the end, 9 times sine squared theta cosine theta. All right, so now we can put these together in the chain rule. So we have dy dx is equal to dy d theta, which is this, negative 2 sine of 2 theta, times 1 over this, which means basically divided by 9 times sine squared theta cosine theta. Now notice what we have to make it equal to is just in terms of single angles. And we know that cosec theta is related to sine theta. That the reciprocal of cosec theta, we know that cosec theta is the same as 1 over sine theta. So it would make sense for me to, hold on a second. Yeah, it would make sense for me to change this now into a single angle. Okay, change this to a single angle. So we know that sine 2 theta from our double angle formulae, which is not in the formula book, but we should know it. The sine of 2 theta is 2 sine theta cosine theta. This is from P3 work and something that we should memorize. If we don't know how to do it, we can go back to P3 work, and you can see how we made this from the double angle formula, from the addition formula. As we know, sine A plus B is equal to sine A times cosine B plus cosine A times sine B. So if it's sine of 2A, we can think of it as being sine A plus A. Okay, sine A plus A, in which case this becomes sine A cosine A and cosine A sine A. All of them are A. So you have 2 sine A cosine A equals sine 2A. This leads you to the formula sine of 2A is equal to 2 sine A cosine A. That's where that formula comes from. So we can use this formula here, okay, to change this. And this will now become minus 2 times 2 sine theta cosine theta. And this is over 9 sine squared theta cosine theta. Now one of these is going to cancel out, and this will cancel out. That will leave us with sine theta in the denominator. So we're left with minus 2 over 9 sine theta, which is the same as, we can think of this as minus 2 over 9. Hold on, this is minus 4. My bad, that's a 4 here, because you have minus 2 times 2. So it's minus 4 over 9, sorry. Be careful not to make silly mistakes. Okay, times, you can say 1 over sine theta, just to think of it like this. And we know 1 over sine theta is the same as cosec theta. So minus 4 over 9 times cosec theta. So we can see here K is minus 4 over 9. And there's the answer to part A. Okay, and this is what we had to show. So we can see here it's in the right form, and K is minus 4 over 9. Okay, so there's the answer to part A. Okay, now we're going to go on to part B. So we found dy dx is minus 4 over 9 cosec theta. This is information already given in part A. It says the point P lies on the curve C where theta equals pi over 6. Okay, find the equation of the tangent to C at P, giving your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. Okay, so we do not know where P is right away. We have to work out where it is, okay, by using these formulae, using the equation, the parametric equation of the curve. Okay, so if we look at these, we're going to find the coordinates of P. Okay, now we need to, so because why do we need to find the coordinates of P? Because we have to find the equation of the tangent to C at P. So the equation of the tangent to the curve C at the point P. So we have to know two things to find the equation of a tangent. A tangent is a straight line, okay? And the equation of a tangent is found by two things. One, a point on the line, which is P, which we don't know what the coordinates of. And two is the gradient of the line, or gradient of the tangent, which is the same gradient that the curve has at the point where the tangent hits it. So we can find that using dy dx, right? We know that at this point theta is equal to pi over 6. So we can find the gradient quite easily from this equation. In fact, let's do that first. So we can say the gradient is equal to minus 4 over 9 times 1 over sine of pi over 6. This is when theta equals pi over 6. Remember, the gradient is the same as dy dx. Okay, so we know that sine of pi over 6 is like the sine of theta, just a half. So 1 divided by a half is like 1 times 2 over 1. So you're going to get minus 4 over 9. Okay, let me just put times 1 over a half, which is minus 8 over 9. Okay, because this is going to be 1 over a half is like 2 over 1, because dividing something by its reciprocal is like the same as multiplying it by. Dividing something by a fraction is like multiplying by the reciprocal of that fraction. So it's 1 times 2. So minus 4 times 2 over 9, that's the gradient of the tangent at P. So the gradient of the tangent at P is equal to minus 8 over 9. So we found that part. Now we've got to find the coordinates of P, which is done easily because we know that x equals 3 sine cubed theta. So the x coordinate of P is going to be when theta is equal to pi over 6 in the equation 3 sine cubed theta. Now remember, 3 sine cubed theta is the same as 3 sine theta cubed. It's just written in this form. So that's what it actually means. So that's 3 times the sine of pi over 6 cubed. Now pi over 6 is 30 degrees. The sine of 30 degrees is a half. So it's 3 times a half cubed, which is equal to 3 over 8. And the y coordinate of P, when theta is equal to pi over 6, is given by 1 plus cosine of 2 times pi over 6, which is 1 plus cosine of pi over 3, okay, which is 1 plus, and that's the cosine of 60, which is also a half. So it's 1 plus a half, which is 3 over 2. So the coordinates of the point P are 3 over 8 for x and 3 over 2 for y. And the gradient of the tangent at P is equal to minus 8 over 9. So putting this together, we can find the equation by y minus y1 equals m times x minus x1. And as they told us, we're going to find them in the form ax plus by plus c equals 0. A and b and c must be integers. So to do this now, I'm going to do y minus y1, which is 3 over 8, equals m, which is minus 8 over 9, times x minus x1, which is 3, this is 3 over 2. The y coordinate, remember this is the x coordinate of P, this is the y coordinate of P, so that's 3 over 2 over x minus 3 over 8. So this is y minus y1 equals m times x minus x1. X1 is 3 over 8. Now I want to get rid of the fractions because I don't want to deal with fractions here. So what I'm going to do is I'll multiply both sides by 18. Why 18? Because that's the LCM of the denominators on both sides of the equation. Lowest number that both of them fit into. So if I multiply everything by 18, I'll have no fractions left. So this is going to be 18y minus, if I multiply this by 18, I'll have 18 times 3 over 2. That's going to be 27. Okay, 18 times 3 over 2. That will cancel with that. 9 times 3 is 27. And this will give me, if I multiply by 18, I'll have minus 16 times. I'll just do it like this first and then cancel it afterwards because I have here minus 16. I forgot about the 8, but still that will help us because what I'm left with here will become something that it goes into. That's fine, no problem. So if I multiply by 18 just to make sure, 9 and 18 cancel out, leaving me 2. Good, that'll be minus 16. Now, if I expand that bracket, I have 18y minus 27 equals minus 16x plus 16 times 3 over 8. That cancels out, leaving with 2. That's going to be plus 6. Okay, so we can now write it in the form wanted. Add 16x to both sides. So I have 16x plus 18y minus 27 minus 6 is minus 33 equals 0. So that is the equation of the normal to this curve at the point. Oh, sorry, the tangent to the curve at the point P. Okay, so point P is somewhere on this side here, somewhere around on this side, positive side, because remember it was 3 over 8 for x and 3 over 2 for y. So it's somewhere over here. Okay, P would have been somewhere over here. Anyway, so now question part C. So this is where we have to show that the Cartesian equation for this parametric is 8x squared equals 9 times 2 minus y cubed, where x is between minus q and q, and we have to also find what the q is here, which is like the domain of this function. Okay, so we're going to go through this question here. Okay, so how do I make the Cartesian equation? What you have to do is you have to find a way of linking these together. All right, a way of linking these together. So what I can see here is I have cosine 2 theta and I have sine cube theta. So I know that x is equal to 3 times sine theta all cubed. right? And I know that y equals 1 plus cosine of 2 theta. I have to find a way of linking the sine of theta and the cosine of 2 theta together. Now they're linked together by the double angle formula for cosine 2 theta, right? So let's just go from the beginning. I know cosine of A plus B is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. We know that from our addition formula. So this is the same. If I change this now to an A, and this will also be A, and this will also be A. I'll have cosine of 2A is equal to, this is cosine squared of A minus sine squared of A. Okay, so cosine of 2A is cosine squared A minus sine squared A. So that's the one double angle formula for cosine. And if I want to find the cosine, the double angle formula in terms of just cosine squared A, then I can change the sine squared A into 1 minus cosine squared A. So I'll have cosine squared A minus 1 minus sine squared A. So I'll end up with cosine squared A minus 1 minus cosine squared A, which will end up giving us cosine squared A plus cosine squared A, which is 2 cosine squared A minus 1. However, if I wanted to take the double angle formula and make it in terms of sine squared A, then this will become 1 minus sine squared A. And this is another minus sine squared A. So I'll end up with cosine 2A equals 1 minus 2 sine squared A. Okay, so now I have the double angle formula for both cosine and, in terms of cosine and sine for cosine squared A. Now, what one would we need if we want to relate cosine 2 theta with sine theta? Well, obviously it's the one which involves the cosine and the sine. Okay, so I'm going to use this form of it to help me here. How am I going to do that? Well, what I can do is I can take y equals 1 plus cosine of 2 theta, and I can write it as 1 plus, instead of cosine 2 theta, I'll put 1 minus 2 sine squared theta. Right? So I've got y equals 1 plus 1, which is 2, minus 2 sine squared theta. Right? Now, how is that going to help me? Well, I can relate sine squared theta in terms of x. Remember, I want to end up with y in terms of x. When I have x and y, I want to get rid of the theta. So I can use some sort of substitution. I know that x is equal to 3 times sine theta all cubed. So if I divide by 3, I get x over 3 equals sine theta all cubed. And if I take the cube root of both sides, I end up with x over 3 to the power of a third. I'll write it in terms of indices for now. And then, so sine theta is the same as x over 3 to the power of a third. Okay, and this is like y equals 2 minus 2 times sine of theta raised to the power of 2. So I know that sine theta is the same as x over 3 cubed to the power of a third. I know this is the same as sine theta. Sine theta is all of this. So I can replace sine theta with x over 3 to the power of a third. So I have y equals 2 minus 2 times, instead of sine theta now, I can write x over 3 to the power of a third, and that's raised to the power of 2. Okay, that's raised to the power of 2, which is the same as saying y equals 2 minus 2 times x over 3 to the power of 2/3. Now let's look at the form that we have to write the answer in, so we can see where we need to go from here. Okay, what we can do here, okay, I need to end up with x squared and y minus 2 minus y to the power of 3. So let's see what we can do here. Let's just rearrange this so this term becomes like a positive term, and we'll subtract y from both sides. So we have 2 times x over 3 to the power of 2/3. It's like I added this whole thing to both sides, and I've subtracted y from both sides. So now it's looking a bit more similar to this. Now, what I want to do, I want to end up with the x squared, but I don't want the cube root thing, right, over 3. So what I can do is I can take all of this side and cube it, and take all of this side and cube it to get rid of this cube root thing. That's like a cube root. You cube it, if you multiply these together, as you have to do when you've got powers, this becomes just squared. So I have 2 to the power of 3, which is 8. I have x over 3 to the power of 2 equals 2 minus y to the power of 3. So it looks like we're almost there. So now we're going to have 8 times x squared over 9 equals 2 minus y cubed. So we're there, basically. We have multiplied by 9. We've got 8x squared equals 9 times 2 minus y cubed. Okay, so that's the expression, the Cartesian form of this parametric equation. Now, they've asked us also to find the domain of this Cartesian equation. Now, the domain of a Cartesian equation, which has been made from a parametric equation, can simply be found by concentrating on the x part of the Cartesian formula, right? This would represent the range of this. Okay, so the range of this will be the domain of the Cartesian equation. So the range is domain when y is a function of x. Okay, when you write it in this form. And here, the range is the range of the function. This, if you want to find the range of this function, it will be the range of the y part. So the range is the range of y equals f of x, the range of the Cartesian equation, right? So we're concerned about this. We want to find the domain. This is the domain. So we need to find the domain of this function here. Okay, so we need to find the range of this function here. That will be the domain of our function. So we got to concentrate on this x equals 3 sine cubed theta. 3 sine cubed theta. Now, what will this look like? Okay, we have theta can be between minus pi over 2 and pi over 2. So what will be the output with this domain? Okay, so we can see when theta equals pi over 2, x is going to be 3 times the sine of pi over 2 cubed, which is going to give us 3 times 1, which is 3. And when theta is equal to negative pi over 2, x is going to be 3 times the sine of negative pi over 2, which is going to, this will be 3 times 1, which is 3. And this will be 3 times, if you got sine of minus pi over 2 is minus 1. Minus 1 cubed is minus 1, so that's a negative 3. So we can see q is equal to 3. So between minus 3 and 3, that's what it's going to be. All right? And just to confirm, you know, if you were to draw the graph of sine theta, it would look something like this. With this domain, it would look something like this. Between minus pi over 2 and pi over 2. Okay? And this would be minus 1 and this would be 1. Okay? So if I was to then multiply it by 3, this would be 3 and this would be negative 3. Okay? Now sine cubed theta, what happens there, okay, is basically all these values get cubed. All these values get cubed, inside here. So basically, if you think about what happens here, all right, the highest value you're going to get when you put, like here, you do what's inside first. So you're going to have, let's start off with 1 and minus 1. Okay, so you're going to have 1 and minus 1. This is y equals 3 sine theta. Y equals sine theta. Okay, now if you do sine theta cubed, this number is going to get cubed, this number is going to get cubed, that's going to stay 1, that's going to stay minus 1, and all these values are going to get actually smaller because they're all like fractions. So for example, if I take a half and I cube it, it's going to become 1 over 8, yeah, even smaller. So these values are going to get smaller, but they won't go higher than 1 or minus 1. And then when you multiply by 3, it's going to become 3, this is going to be minus 3. So you can see that the range of this will never be beyond 3 or less than minus 3. Okay, it's always going to be something which is highest 3, lowest minus 3, because this thing can never go above 1 or below minus 1. Okay, this will never go above 1 or below -1 because, you know, you've got values between -1 and 1 that it can be. You cube any value. If you cube 1, you're going to get 1. Cube -1, you get -1. If you cube any fraction between them, they're going to always be smaller than 1. All right, and then you multiply by 3, you're going to get 3 and -3. So we can see here that Q is going to be definitely equal to 3. Okay, this is going to be between -3 and 3. So there's your answer to question number 3. Okay, and I hope that was clear. Other questions from this particular paper can be found in the playlist, which will appear on the top of the screen at the end of the video. You'll see the link for the playlist, which involves parametric equations. In the bottom right, you can subscribe to the channel by clicking on this link. And here you will find a video which tells you how to use my channel to find what you're looking for. Thank you for watching and see you soon.